Okay, so the Monarch lathe that I've got, the Monarch Merit lathe, came with this 8-inch Bison 3-jaw chuck. Along with this Bison 3-jaw chuck, I've got 12-inch faceplate to go on it. So this lathe has got a long taper spindle on it. L0 size. As you can see, it's got a taper with a keyway in it. In order for this lathe to be more versatile, I need a 4-jaw chuck to do odd size and accurate work. So to fit my budget, I picked up this 12-inch import 4-jaw independent jaw chuck. So this is known as a plain back chuck. I can flip this over. As you can see, this does not have the mating taper to go on the lathe. But what we need is this taper. So this is a chuck adapter plate. It's just kind of a rough machined out. It's got the proper taper to mount on this spindle, but it's made for a different chuck. So the pilot diameter of the chuck I have is about this diameter of this inner step. So I'm going to have to turn all this off, this excess off on the outside, and then once this gets it to be a good fit inside the new chuck, I'll have to transfer and drill and tap the 4 mounting holes to hold that chuck to this adapter plate. So I don't know how well this will show up, but as part of checking the fit of this lathe back plate, I put a little glue on the nose of the spindle and mounted the adapter. It's kind of faint. I don't know how easily you can see that, but it seems to be getting pretty good contact on both of those parts of the registration taper where the spindle nose sits. So I'm pretty confident this is pulling up nice and tight and square. Just to give you an idea what I'm talking about here, this is the L0 taper. This is the retaining nut that holds the chuck or the back plate or whatever you want onto the spindle. This is the spindle nose. So I've got a indicator set up on the spindle nose here. That's a half thou per line resolution indicator, about 12 micron per line indicator. I don't know if you can see that there, but there is minimal run out in that spindle. In fact, you can even see how good the bearings are. I can't even hardly move the indicator at all. Not even a 1/10 of a thousandth. So what I'm concerned about is that this is really super clean. So I've gone through here and I've cleaned this up. Got all the little chips, the burrs off. I guess that's kind of the disadvantage of the long taper, is it's easy when you're changing it to get a little chip or something behind here and get it jammed in there and give run out in your chuck. So clean this really good. I've gone over it really lightly with a small polishing stone. Look for any high spots in there. Your hands are really good for finding any kind of grip. I've also cleaned out, de-burred and cleaned out the inside of the spindle adapter plate. So there's a key to line up here. start that nut. Large spanner wrench to tighten it up with. I've got the spindle in high gear right now. I want to pull the spindle back myself for tightening up. I don't want to rely on the gears in there and be banging on my gears. See, I'll take a soft hammer and hammer on this wrench. I don't want to be hammering on the gears inside the headstock. That should be pretty tight. What I'm going to do now is there's a center bore we're going to look at. Actually got the spindle in neutral. So I'm only seeing maybe half a thou of deflection on there. So I'm pretty confident that this plate is on tight and correctly. With no chips or dirt underneath. That is the important thing. Just for curiosity's sake, let's see what, I don't know if I can get this where you can see it. These test indicators you gotta keep about a 12-degree angle on the tip there to be precise. We're just seeing what it looks like anyways. I feel like neutral. There it is. So I've got about 1.5 thou run out on that face, which is not bad for something who's just rough machined like this. See what the outer diameter run out looks like. You see that? I can't hardly see it. It's like the outer diameter doesn't have 1/2 thou in there. So I'm pretty confident that this adapter piece is on the spindle properly. The pilot on that four-jaw chuck is 6 inches. You can see this inner diameter is 8 inches. So I've even got to go down beyond that. So this is what I'm referring to over there. That the shoulder on that adapter is about 8 inches, but this has got a 6-inch bore in the center. You see it's got this machine register here. If I locate on this surface, I'm going to cut that down to about 8 inches, registered on this surface and inside this diameter here. Okay, so the story so far, I've gone and roughed down this outside diameter. I've left about 20 thousandths on here to finish. I want to rough this all out first. I think it's probably good practice in removing this much stock. Rough everything out first, then come back and finish everything, starting with your least important features like this outer diameter and finishing with the most important features like the registration face and diameter on this. So that way, in case something moves a little bit, moving so much stock that it's all done, moved before the finish cuts are taken. So this is going to end up at about 7.5 inches in diameter, just over 190 millimeters. Got to cut the shoulder out. I made some rough marks with a marker on here, just a little oversized. That'll give me a spot to start out roughing down to, so I don't have to worry about measuring it until I get it closer. Like I said, I'll probably take this diameter down. I'll probably leave 10 or 20 thousandths on there too. Come back, finish the outside diameter, face the whole thing off, just to make sure this whole face is flat. It should be clearance on that face, so it just doesn't matter a whole lot. And then I'll go back in here, finally finish the registration faces. Okay, so that should give me about 40 thousandths to go, 45 thousandths to go. So as I get closer, I'll use a depth mic on here, make it a little more accurate. See if we can get a better surface finish on it too. This casting doesn't seem to be turning the greatest. So I probably could have picked a little better tool than a facing tool to rough this out, but once I get closer down there, I'll decrease the feed rate and see if we can get the surface finish to clean up a little. It's a little rough there. Diameter, well, that's quite a bit oversized. Rough numbers, I'm about 160 thousandths oversized on the diameter, so I'll turn that down, get this diameter within 40 thousandths. So I've got everything roughed out, 40 thousandths or less. I've gone ahead and finished this outside diameter, least important diameter. It doesn't serve any function. Next I'm going to go and face this off here. This casting isn't the greatest. It's hard to get a real good surface finish on it, but we'll see how this facing tool I've got works on here. Might be a little sharp for getting a good finish on here, but let's see what we got. Start with just a light cut, see how it cleans up. Real slow feed rate, try to get a decent finish. Feeding about 8 thousandths per revolution, running 100 RPM, so this will take a minute. And I'm only taking 6 or 7 thousandths off there, but it seems to be cleaning up pretty decent. So. Well, I seem to be having problems getting my camera in real close. You can see this tool cutting. I don't want all the cast iron dust coming off here. I don't want to fill my camera and my microphone up with that stuff, but hopefully you can see what's going on. So I'm getting this pretty close now. Got about 4 thousandths to go to get this step where I need it. Of course, there was no mounting instructions that came along with this, but I found a similar chuck from another manufacturer which mounts the same way, and they recommended leaving about 1/2 millimeter, around 19 thousandths or so gap between this non-registration face and inside of the chuck. So that's what I'm shooting for. That'll finish this face off. It's got a decent finish on it. So now I'll prepare for this registration diameter, probably the most critical feature as far as size goes on here. So I've gone and done some careful measuring of the bore on the chuck using my inside mic here. Compared it against some outside mics. Looks like my final dimension needs to be just under 5.9852. So I'll shoot just under that, 2 to 4 tenths under that, just to give it a slit fit. I've gone and taken a pass on here. Got about 6 thou to go. Now I wanted to get a decent finish on this, so I've got a rather large radius finishing tool in here. I can't quite get into the corner. I don't need a real sharp corner in here. I just needs to be cleared. So once I finish this surface here, I'll go back in with a sharper pointed tool and I'll just nibble out that corner just to make sure it clears. Cast iron dust off there. So I take 4 thou off there. It should put me just a hair undersize, right where I want to be. Take 1/1000 more. Let's show me just where I want it. 4/10 undersized. So I'm going to take my facing tool. It's got a nice sharp point. I'll nibble that corner out. Put some chamfers on here. Chamfered all the corners of the chamfer tool. It's all cleaned up now. Should fit on there. I'm going to try this chuck on here. It's a fairly heavy chuck, so put this board on here. Not only does it give me a place to set it, if worst case happens, I drop it, it'll keep me from damaging the ways on the bed. So this is a fairly heavy chuck. I'm going to take the jaws out of it just to take every little last bit of weight off I can. So it's a moment of truth where this fits up on here. There we go, it's a little snug. Okay, so there it is, it fits. So next steps, I'll take this back off here. We want to transfer these 4 holes. Here's the finished adapter. See, I've gone through and got the holes drilled and tapped in here and chamfered. Everything's pretty clean. I've gone through and cleaned it with brake cleaner, so I want to get some oil on it here pretty quick before it rusts on me. But I don't know if this is normal cast iron, because it was kind of different when I was turning it, but when I went and drilled and especially tapped these here, it worked pretty hard to thread those. So got a couple of guide pins here I've made up. Just to help me get this chuck started on here, because as we know, it's a fairly snug fit on here. I'll take the chuck, all the registration faces, make sure it's all clean, there's no burrs on it. Now, another thing I'm going to do to ensure that these screws stay in the center of the holes, I'm going to put, I took some aluminum flashing, which is just under 25 thousandths thick. I'm going to go ahead and put these in the 2 holes that I'm going to use for alignment here. You know, it's not a real tight fit on the screw, but it's enough that once I pull them out, you know, I'm going to be guaranteed that I'm at least that thickness off the walls of these screws, just to ensure that the screws are not touching the sidewalls in there. Hoist it up. There, that shim come out. Run these down, draw it down in with the screws. Okay, it's down. These shims out of here. Let's see how good that's centered in the hole there. Nowhere near touching the sides. That might not be absolutely necessary, but I'm going to put just a drop of blue Loctite on here. I don't see where I'm going to be taking this adapter off this chuck anytime soon, so the blue's not going to be permanent, but given this is a rather large chuck, let's make me feel better anyways. So another thing I'm going to do, which probably isn't absolutely necessary, might be going too far by some standards, but I'm going to put a torque wrench on these and bring them down to torque here, and gradually work them in. I don't know if it matters, but in my mind, I'll be putting even pressure on the chuck. Like I said, probably doesn't mean nothing, but
but I'll do it anyways. These are class 10 screws here, 10.9 I believe, metric. That should do that. So now what I'm going to do is, this is all clean, there's no oil in here, it's going to rust. I'm going to go through and lube this, but first I notice a lot of these guides in here for the jaws, they got quite a few burrs on them, so I think that's the one disadvantage of disadvantages of buying an import chuck is they don't always do all the finishing steps on it. So I'll go off camera here. I'm going to deburr this all, oil it all, get the jaws installed, and we'll go from there. So I've got it all cleaned up, deburred all these slots. The jaws themselves were pretty good. They really didn't have any burrs on them. They're a pretty good finish. There's a lot of grit and everything, which I find is typical for these lower cost chucks. You know, they've got to make a profit too, so I'm sure they want to pay somebody to clean them, so, which is fine. You know, that's what is expected. Which is expected with this. But it cleaned up really nice. Put a little light oil in everything just so it doesn't rust. Put a little heavier oil, put some Vector oil, a little bit in these screws, a little bit on the slides of the jaws. Probably put a little more oil on there than I should have. I'm probably going to pay for it when I start it up. Fling oil all over the shop here, but start slow and see what it runs like. See the oil falling out of it. .70 RPM. Don't feel any abnormal vibrations or nothing. So I think that'll do us pretty good. Hopefully you learned something, or at least enjoyed this video and inspired you to do some more research on your own. Thanks for watching, and if you haven't already, maybe consider subscribing and pushing that like button. Helps out the channel. But see you next time.